So now let's start with the remaining problems. So in the rolling process, your V0, H0 and Vf are the seat velocity and seat thickness before and after rolling respectively. If width of the seat is constant, so as we were solving this, so as we have already discussed, the correct answer will be your first A1. Now coming to the neutral point, your velocity of the roll is equal to the velocity of the seat. Now coming to the next problem. So if a seat is a seat plate of 20 mm thick is to be rolled to 14 mm in a 4 high rolling mill having roll diameter 480 mm. If the given reduction is maximum reduction possible, then the coefficient of friction is. So this will be again can be solved as your nu is equal to tan alpha, and then your tan alpha can be written as delta h by r to the power half. So by solving this, and delta h will be your 20 minus 14, so your sixth will be your delta h. So this can be written as 6 by r is your 240 mm to the power half. And then from here we will get the alpha as 9, so then put it in here this, and then you will get the answer. And then comes the 4 mm thick seat is rolled with 300 mm diameter rolls to reduce the thickness without any change in the width. The friction coefficient at the work roll interface is this. And what is the minimum possible thickness of the seat that can be produced in a single pass? So for solving this, what we will be doing, as we have solved many problems previously. So your initial thickness is h1 is given as 4 mm. Then your roll dia is 300 mm as it is given. So we will nu is 0.1 is given. So we can write your h1 minus h2 as nu square times r. So your h2 can be written as your h1 minus nu square r. So from this we can solve it as 2.5. So as the recording wasn't saved, so I will be recapitulating again what we discussed. So in this week, generally, majorly forging and rolling were discussed by Professor Jha. So we discussed this only. So let's discuss again like what we discussed. So in this, so firstly I discussed about how ruling process is, like how the different formulas were derived. So here we are talking about, so there was a strip which was being rolled between the two rollers. So due to this, the thickness was reducing from h0 to hf, and then the rolls dia we discuss about the roller. So there is an angle of bite between the roller and this, which is generally uh, has a range from 3 to 4 degrees. Or then we find the we discuss about what are the different terminologies. So then we wrote cos alpha as d minus delta s time d. Then your tan alpha should be less than or equal to your nu, and then we find out the maximum bite angle condition. After that, I wrote the different formulas, like for the minimum number of passes, your delta is it can be calculated as the ratio of delta h required by delta h maximum. Then your elongation formula or elongation ratio for single pass and for n passes. After that, I wrote like how we can calculate the power requirement in rolling. So power required in rolling can be calculated as, firstly we have to calculate the projected length, which is given by LP, or it is R sine alpha, which is root times R delta S. Then after that, after finding the projected length, we find projected area, and then projected force, and then your arm length. And after that, I discussed about the different operations in the forging. So firstly, a full ring, then followed by aging, bending, drawing, flattening, bending, finishing, and then trimming. Then we find out the different. Then we did the various uh, numericals. So I will be uploading those as the video wasn't saved. So still I will be uploading those. So if any students have any doubt in any problem, we may discuss this. Okay, so I'm wrapping the session. Then